Whoa. Imagine building a fully working flight simulator right in your browser and doing it for half the usual cost.
I mean, it genuinely sounds like pure science fiction right now.
It really does. Welcome to today's deep dive. We are jumping straight into a massive shift in AI coding. We are unpacking a highly anticipated new model.
Yeah, it's called Kimi K3.
Right. And the current hype around this model is absolutely staggering.
It's intense. I mean, demand is so incredibly high, they actually paused new subscriptions.
Existing users can access it, but newcomers hit a waitlist.
Yeah, that kind of severe bottleneck is exceptionally rare today.
It happened immediately after Kimi K3 defeated Fable 5. It dominated the leaderboard and just became an overnight sensation.
But standard leaderboard stats are ultimately just abstract numbers.
Exactly. The real question is practical application for your workflows. What can this model actually do for you?
Right, in the real world.
Yeah. So to figure that out, we have a clear roadmap. We are exploring its engine room and its underlying architecture. Then we are analyzing its notably premium price tag.
And then we get to the really fun stuff.
We do. We are reviewing a head-to-head tennis ball test. That is Kimi K3 against Opus 4.8. Finally, we'll break down 3 wild, real-world coding demos.
I am so ready for this. Let's get right into the technical details.
Okay, let's unpack this. To understand the hype, we must look under the hood. How does Kimi K3 handle massive amounts of complex information?
Right. How does it manage that without losing its train of thought?
Exactly. That seems to be the core underlying challenge for all AI.
Oh, absolutely. It's the big hurdle.
So Kimi K3 is positioned as a premier flagship model. It is expressly built for coding and highly complex reasoning.
It handles visual understanding and full end-to-end knowledge work.
Right.
It basically stays with you across the entire project workflow. You feed it raw code, long documents, and structural images.
And you can assign it multiple connected tasks over a week.
Yeah, and you never have to re-explain the core project parameters.
Which is huge. That brings us to its most significant technical upgrade. The massive 1 million token context window.
It is massive.
I like to think of this context window like a massive desk. You can leave all your architectural blueprints open at once. You never have to pack them up or put them away.
That is a perfect analogy for visualizing the active memory. You just don't have to split large projects into tiny prompts anymore.
But wait, before we move on, what exactly is a token? Let's clarify that for everyone.
Sure. Think of a token as a small fragment of a word. 1 million tokens essentially equals a massive library of reference books.
So how does the model effectively manage that massive desk?
Well, it relies on 3 highly specific architectural framework components: Kimi delta attention, stable latent mo, and attention residuals.
Yeah, those are some incredibly heavy technical terms.
They definitely are, but they solve a very critical processing problem. They help the model follow complex information across long sequences.
Let's actually define that first term, Kimi delta attention. What is the delta actually doing in that process?
So delta fundamentally just means calculating the difference between 2 things. Normally, an AI model rereads the entire context window every single time. Delta attention only processes the specific new data that just changed.
Oh, wow. So it ignores the rest of the static information entirely.
Exactly. That targeted focus is how the engine stays so incredibly fast.
That makes total sense. Let's break down that second technical term. What is a mixture of experts, or MOE?
It means routing a task only to the specialized brain areas needed.
Okay, so it doesn't activate the whole network at once.
Right. Stable latent mo only wakes up the specific experts required. It saves immense computational energy during complex problem solving.
Then you have the third component, the attention residuals. What is their specific role in this massive engine?
They act as a critical memory bridge across the network. They carry vital early details forward into the final processing layers. 2 sec silence. It essentially stops the AI from forgetting the original prompt.
That is crucial for long-running multi-step engineering tasks. The official documentation also mentions 3 distinct reasoning effort levels.
Yes. Developers have 3 clear options: low, high, and max.
And max is the default setting right out of the box, right?
It is.
So why wouldn't you just leave it on max forever?
Because max expends significantly more computational energy and processing time. You really have to test them yourself to find the efficient sweet spot.
There is another major feature here called automatic context caching.
Oh, yeah. This specific feature is an absolute game changer for developers.
How so?
Well, if a massive prefix of initial information stays unchanged, the model caches it. Later requests just rapidly reuse that heavily cached context.
Mm-hmm.
It skips processing the entire foundational document from scratch.
How much time does this context caching actually save a developer in reality?
It avoids constantly rereading massive code bases. I mean, not having to reprocess 50 unchanged files for a minor tweak saves hours.
So it remembers the baseline setup to save massive amounts of processing.
Exactly. It makes the entire iterative workflow feel incredibly immediate.
Having all those vast blueprints on a massive desk is phenomenal. But renting that premium desk space comes at a premium cost.
It always does in the AI world. Processing power is never cheap.
Let's clearly lay out the token economics right here. Input tokens cost $3 per 1 million tokens processed.
Right.
Output tokens cost $15 per 1 million tokens generated.
That output cost is a highly significant jump from earlier models.
It really is. It changes how you interact with the system.
Yeah.
I mean, if you just need a tiny code edit, it is total overkill.
Yeah, you are simply paying far more money than you actually need to.
Right.
What's fascinating here is where the real enterprise value unlocks. The value proposition completely flips when tackling massive software projects.
How exactly does a higher cost create better enterprise value?
Because Kimi K3 delivers a vastly stronger first draft result, it follows highly complex project rules much more accurately.
Right, and that accuracy means you write fewer follow-up prompts.
Exactly. It drastically reduces the number of tedious revision prompts you need. You spend significantly less time manually correcting the AI's logical errors. That massively saved engineering time quickly offsets the higher token cost.
I want to look at this from a different angle. You are basically hiring a high-priced digital consultant by the minute.
Yeah, that's a good way to look at it.
You don't want them brainstorming abstract ideas out loud. You want them executing a highly specific, pre-approved plan.
That is a very accurate way to frame the financial relationship.
Could this high output cost backfire if the AI hallucinates a huge block of useless code?
Oh, absolutely. That is a very real financial risk for users. If it confidently generates thousands of lines of pure garbage, you still pay.
Right. Mistakes get expensive quickly if you don't steer it carefully.
You have to be incredibly intentional with your instructions. Precise, upfront prompting is absolutely essential with this premium model.
That actually connects perfectly to our next major topic. We know the engine specs and the high price tag, but how does it genuinely behave in the real world?
Yeah, we really need to see it handle a truly vague instruction.
I have to offer a vulnerable admission here. I still wrestle with prompt drift myself when I give vague instructions. I just completely lose track of what I originally wanted to build.
We all do that. Vagueness is the absolute enemy of good, functional code.
That is why this next community test is so revealing. We are looking at a head-to-head tennis ball test.
It is a phenomenal stress test for measuring artificial initiative.
Both AI models were given the exact same bare-bones prompt. The prompt was simply, make me a website on tennis balls, please.
That is an incredibly minimal instruction set for a developer. There were absolutely no design guidelines or layout instructions provided.
None at all. The models had to decide what to build entirely independently. Let's look at the Opus 4.8 result first.
So Opus 4.8 built a very clean but notably narrow site. It went for a bold, highly contrasted visual style.
Right. It used a dark background with bright tennis green highlights everywhere.
Yes, it utilized heavily oversized typography for dramatic visual impact,
Yeah.
but the actual graphical elements were completely static and lifeless.
Its main message focused heavily on the internal pressure of the ball. It showed a rigid cross-section of the manufacturing materials.
Yeah, it calmly explained the internal pressurized air mechanics. It
Yeah.
listed the rubber core and the chemical adhesive.
Right.
It even detailed the specific wool-nylon felt blend used.
It was a highly clinical, highly structured educational approach.
It was undeniably a good conceptual landing page, but it stayed very rigidly close to the literal basic topic.
Now, let's sharply contrast that with the Kimi K3 result.
Kimi K3 produced something totally different. It was highly active and surprisingly initiative-driven.
The very first thing you see is a large moving tennis ball. The entire web page felt alive and interactive immediately.
And it certainly didn't stop there. It aggressively added multiple detailed interactive sections. It dynamically broke down the core, rubber shell, adhesive, and felt.
And it added full working site navigation menus. It included very clear call-to-action buttons for potential buyers. It even spontaneously invented a Find Your Ball functional feature.
That is the crucial so what of this entire comparative test.
Let's dig into the underlying mechanism there. How did it logically know to add those commercial features?
It successfully maps latent user experience patterns across the web. It understands that tennis balls are commercial products meant to be sold.
Right.
It inferred strong commercial intent without being explicitly told.
It made independent choices about what makes a website feel complete. But honestly, as a developer, that unpredictability terrifies me slightly. Is there a danger of the AI taking too much initiative and ignoring the user's actual brand voice?
Yes, that is a highly valid enterprise concern today. That level of initiative is fantastic for quick, messy prototyping. But if you have incredibly strict corporate branding guidelines, it might rebel.
It is a delicate balance between saving time and losing your creative control.
Exactly. You want a helpful technical assistant, not a rogue art director.
Still, generating a static website, even a nice one, is one thing. Can this model handle highly complex dynamic browser logic?
Right.
Can it accurately handle three-dimensional rendering and movement?
The broader developer community desperately wanted to know that too. People immediately started rigorously testing its limits on X.
There are 3 highly verified demos on X we need to discuss. They definitively prove Kimi's current dominance in complex front-end development.
Let's look closely at the very first viral demo. This was Kimi K3 matched directly up against Fable 5.
They were independently asked to build 3 completely distinct front-end projects: an e-commerce site, a 3D fighting game, and a flight simulator.
Kimi K3 didn't just lazily recycle a standard underlying layout. It adapted beautifully and functionally to each highly unique task. The visual graphical output was consistently strong across all 3 domains.
The second verified demo is even wilder to consider. It was asked to comprehensively rebuild macOS 27 as a working web app.
Running entirely inside a standard browser window. That is an incredibly complex engineering feat.
It perfectly nailed the famous liquid glass visual style.
What truly impressed me was the underlying state management. That liquid glass style requires highly complex CSS backdrop filters.
Yeah.
It requires meticulously managing overlapping layers when dragging separate windows.
The AI has to hold all that visual context at once.
Exactly. It flawlessly kept that intricate visual style identical across multiple simulated apps.
The browser experience genuinely felt like a native operating system.
It really did.
Then there's the third highly discussed demo. This rigorously compared Kimi K3 directly against GPT 5.6 Sol.
They both attempted to construct a browser-based flight simulator.
But a real flight simulator demands constant physics calculations.
Right.
It needs highly responsive keyboard controls for pitch and yaw. It fundamentally requires complex, uninterrupted working browser logic.
Kimi K3 successfully delivered all of those complex interactive elements, and it amazingly did it for about half the token cost of GPT 5.6 Sol.
Half the token cost for a fully functioning, responsive browser simulation.
If we synthesize all this data, Kimi K3's current superpower is incredibly clear.
It dominates visual coding and highly interactive graphical interfaces.
Yes, it exceptionally excels at game-like web apps and creative front-end visual work.
We should specifically note a critical caveat from the documentation, though. Larger back-end architectural projects and complex debugging still require significantly more testing.
It frankly hasn't proven itself on deep server-side logic just yet.
With front-end this good, are back-end developers safe for now, or is that next?
Deep back-end logic is simply much harder to visually verify in a quick demo. It takes considerable time to thoroughly security test. But looking at the trajectory, back-end dominance is inevitably the next frontier.
So it excels at visuals, but complex back-end logic remains a question mark.
For now, yes. The industry focus today is clearly on mastering the visual layer.
We're going to take a very quick break. When we come back, we will look at the big picture: mid-roll, sponsor, read, placeholder.
Welcome back. So what does this all mean for us? Let's zoom out to the 30,000-foot industry view.
If we carefully synthesize everything from this deep dive, a clear picture emerges.
Kimi K3 is an absolute powerhouse for highly creative coding. It represents a massive evolutionary leap for front-end interface development.
Its truly unique ability at taking a tiny, underdeveloped seed of an idea, like our incredibly simple tennis ball prompt example.
Right. It takes that tiny seed and comprehensively architects a complete draft. It builds a highly logical and functionally interactive first iteration.
It intelligently anticipates what specific features you need before you even ask. So who is this premium tool actually built for? The ideal commercial use cases are pretty specific right now.
It is absolutely perfect for software developers needing incredibly quick prototypes, front-end design teams creating highly visual, interactive websites will absolutely love it.
It is also exceptionally great for managing massive multi-file code bases.
hmm
That 1 million token context window is doing the heavy lifting there.
Yeah, if your daily work demands strong visuals or incredibly long project context, it's worth the waitlist.
Here's where it gets really interesting for the future. We have literally seen it hallucinate entire operating systems. We have seen it logically build 3D games from a single descriptive sentence.
If we connect this to the bigger picture,
Yeah.
it makes you question the future of the web.
Exactly. How long until the traditional concept of a static website is replaced entirely? Imagine highly complex interfaces generated in real time just for you.
Right.
They adapt perfectly the exact moment you click a specific link.
A completely dynamic web that fluidly builds itself around your specific intent.
It goes right back to the incredible browser-based flight simulator. You aren't just downloading rigid prepackaged software anymore.
No, not at all.
You are literally speaking functional digital worlds into existence right inside your browser.
It represents a truly profound shift in how we fundamentally interact with machines.
It truly is a remarkable technological leap. That is all the time we have for today's deep dive. Thank you for thoroughly exploring the digital frontier with us today. Stay perpetually curious, and we will catch you next time.